Anna, I'm trying to make a video.
Anna, I might be able to help you.
Go turn it in. Okay, so, good lord. Okay, so on number 38, we're trying to take the fifth root of 192 x to the fourth y to the sixth. So, if you look at the powers of 5, I've got 32, I've got 243. Just so everyone knows, my 7th period is really weird. Okay. I am not saying hi to Shirley. Okay. The fifth, 2 to the fifth is 32, 3 to the fifth is 243, and 243 does not divide into 192. So the only option I have for taking the fifth root is hoping that 32 divides into it. And if you actually try it, 192 divided by 32, you get 6. So this is 32 times 6. And I know the fifth root of 32 is 2, because 2 to the fifth is 32. So when I think about taking the fifth root of that, that is 2. And I have to leave the 6 inside. And then I have to ask myself, how many times does 5 go into x to the fourth, and or into 4? And it doesn't. So you have to leave x to the fourth inside. How many times does 5 go into 6? And it goes into it once with 1 left over. Okay? So your final answer is 2y times the fifth root of 6x to the fourth y. Okay? On 39, we got to take the square root of 100x squared y cubed. So the square root of 100 is 10. And that's an understood 2 right there. So how many times does 2 go into 2? 1 time with none left over. And how many times 2 go into 3? 1 time with 1 left over. And so that's your answer. Okay? On 40, we have to take the square root of 144. So the square root of 144 is 12. And then you have to think, how many times does 2 go into those powers? So 2 does not go into 1. So I leave x to the 1 inside. 2 goes into 2 for y squared once, with none left over. And then 2 goes into 3 for z once with 1 left over. And so your answer is 12yz times the square root of xz. Okay? Now, if you do not listen to Kayla, I have authorized her to stand up and yell at you. Okay? And by yell, I mean very quietly glare at you. Okay? Because I'm trying to take a video. Okay. That was really loud in a video. The fourth root of 243. So I need to look at powers of 4. So 16, 81, 256. Okay, 256 is too big. So I've only got options 81 and 16. And so I'm thinking I'm going to try 81. But if you think about, like, what do you have to multiply 1 by to get 3? And it's 3. And 8 times 3 is 24. So yeah, 243 is 81 times 3. And the fourth root of 81 is 3. So I've got the fourth root of 81, which is 3. And then I've got to leave the 3 inside. Okay. And then I ask myself, how many times does 4 go into 8? 4 goes into 8 twice with none left over. How many times does 4 go into 14? Well, 4 times 3 is 12. So 3 times with 2 left over. And then how many times does 4 go into 7? And that is 1 time with 3 left over. So, and be careful, because right now that kind of looks like z to the fourth. And a lot of people, if you have a power right there, you forget to do the root. So think about that. So your final answer is 3x squared y cubed z times the fourth root of 3 y squared z cubed. Okay? Okay. Now on number 42, we're supposed to simplify the expression, and in this case what I want you to do is multiply, so distribute. Okay, so I've got 3 times a negative 1 is a negative 3. 3 times the square root of 2 is 3 square roots of 2. Square root of 2 times negative 1 is negative square root of 2. And square root of 2 times square root of 2. Square root of 2 times square root of 2, you can think of it as a couple different ways. You can think of it as the square root of 4, which is 2, which is like doing square root of 2 times 2. Or you can think of it as the square root of 2 squared, cancels out and you're left with 2 anyway, okay? So either way, square root of 2 times square root of 2 is 2. And then what you need to do is combine like terms. So I've got 3 square roots of 2 minus 1 square roots of 2, and that is 2 square roots of 2. And then I've got negative 3 and positive 2, which is negative 1, so negative 1 plus 2 square roots of 2. Rational numbers are always written in a plus b square roots of c, okay? Just like imaginary numbers are written a plus bi, okay? So if you can, put the root on this side. Okay. Now on 43, what we're trying to do is rationalize, which means you do not want the square root in the denominator. Right now we would call this an irrational expression. Now, I don't know if you remember, but when we had problems like this, if I had 2 plus the square root of 7 over negative 2, let's go with negative 3 minus the square root of 7, we would rationalize by multiplying by the conjugate, negative 3 plus the square root of 7 on top and bottom. The idea is to get rid of the square root. But I don't actually have to do that. I don't have to change the sign in order to get rid of a square root, because the only thing you have to do to get rid of a square root is just like if you're not dealing with an equation, because an equation you can square both sides. I can't do that. It's not an equation. It's just an expression. So what I can do is multiply the top and the bottom by just square root of 3. Now, I can multiply by 5, but I don't have to. If I do that, I'm going to have to divide out the 5 at the end anyway. I might show that anyway, just so you can kind of see. So I need to multiply top and bottom by square root of 3, because in effect you're multiplying by 1. You need to multiply something by. When you multiply by something divided by itself, you're multiplying by 1, and that really doesn't change an expression. So I'm going to distribute. Negative 5 times the square root of 3 is negative 5 square roots of 3. And square root of 3 times 3 square roots of 5. So square root of 3 times 3 square roots of 5 is just the numbers in the front multiplied times each other, and then the numbers inside the square root multiplied times each other. So plus 3 root 15 over 5 times the square root of 3 times the square root of 3. Well, square root of 3 times square root of 3 is just 3, and 5 times 3 is 15. So this is my final answer. I cannot simplify 5, 3, and I can't simplify 5, 3, and 15 because they don't all divide by the same thing. And I definitely cannot divide the square roots by a number not inside the square root. So we're done. If you have multiplied by 5 square roots of 3, though, let's just say that real quick. So if you multiply the top and bottom by 5 square roots of 3, or even negative 5 square roots of 3, if you were thinking like conjugate, the opposite. If you do the negative, you're going to have to float the negative top anyway and get rid of it. So what you can just do is do this. You get 5 times 5, which is 25, times 3, which is 75. And then you get negative 25 root 3, and you get 15 root 15. But 25, 15, and 75 all divide by 5, so divide by 5, divide by 5, divide by 5. Just kidding, divide by 5, that's 15. It's dividing by 3. Which gets you back to this. So if you don't have to, then don't multiply by the 5. Okay. So now what I want to do is on 44. I want to write the expression in radical form. Well, right now this is an exponent, okay? It's an exponential form. So what I want to do is remember that this is the power and this is the root. Just like a tree, roots are on the bottom, okay? So it's the square root of 5b to the first power. If it's the first power, I don't need to write anything. So there you go, okay? Whereas on this one, it's the fifth root, because roots are on the bottom, of x to the third, or the fifth root of x to the third. They're equivalent. Okay? On 46, you need to do the opposite. So this is 3n, all of 3n, okay, so being raised to the power on top, root on bottom. Okay, so 3n to the 3/5. And then on this one, 2x, the power is, there's not a power written, so it's an understood 1, and the root is on the bottom, 3, so 2x to the 1/3. I do want to be clear about something though, because if you had a problem like this on 44 or 45, because in a lot of problems you're working, you have something like 3x to the, I don't know, 2/5. Well, you guys like to treat it as this, and that's not equivalent. The only thing being raised to the 2/5 power is the x. If I had meant this, then I would have written this. Okay? That is that. This right here only means 3 times the 5th root of x squared. Okay? So you need to be careful about doing this, because a lot of people are lumping in this 3 with that x, and that's just not true. Okay? But anyway, that is the answer to that. And there we go. Okay. And so, there you go.